Apollo 11 carried 2 astronauts to the surface of the moon. This day is celebrated as International Moon Day. Today at NRSC, we are happy to celebrate Moon Day with your gracious presence. We are happy to inform that this program is also broadcasted to all schools across Telangana with the support of SCERT and TSAT. I request Director NRSC Dr. Prakash Chauhan to give presentation on International Moon Day.
United Nations has declared that we should celebrate Moon Day on this day of 20th July every year. India also has made significant work in terms of doing lunar exploration with our missions called Chandrayaan-1 and Chandrayaan-2. And we are also now planning about Chandrayaan-3. This photograph has been captured from a position in solar system called Lagrangian points. So there is a satellite of NASA which operates from Lagrangian point, and this has captured this beautiful image of Earth and the moon going around the Earth. So what is the basic difference you can see between moon and Earth? The Earth is a blue pan. The colors, you see the color. The Earth is basically, moon must have been formed long back. In fact, it has formed around, when the solar system was forming, around 33 billion years. First, let us understand that how moon must have been formed. So there are a lot of theories, which has been postulated by various lunar scientists. And one of the most accepted theory by various scientific, lunar scientists is that moon must have formed by what is known as the giant impact theory. So this RIA is basically, it collided with the Earth. And this collision was so huge that a huge amount of mass, it got scooped out from this molten Earth. The Earth has not solidified by that time. And then it started going around as an accreted ball. And over a period of time, this particular material which came out started going around, and slowly, due to the planetary sweeping process, the moon got formed. That is one hypothesis, and this hypothesis or theory is known as the giant impact theory. And then with the gravitational influence, it started going around this primitive Earth. And that's how the moon formation has been explained. They will start sinking. They will go towards the interior of the moon surface or any planetary body. So this is how the core of the moon or the internal material of the moon, basically now if we see, we have some evidence for that also. It is made of elements which are much heavier. They are basically made of magnesium, iron, they are magnesium iron silicates, and then there are other kind of silicates are also there. So essentially, the heavier elements are towards the core and the lighter elements are on the surface, and this particular process is basically known as a theory again. It's called theory of differentiations of planets, and in the case of moon, it's called the giant magma ocean theory. That means there was a huge magma of molten material, and then crystallization happened, and the current form of the moon basically after solidification process has been, is there, whatever you see. Without coming in physical contact to each other, this is remote sensing. Anything which we sense with a physical separation can essentially be termed as remote sensing. So we also started, people started sending these probes or remote sensing probes to know more about Earth in different fashions. So early days when the rockets were not developed, people sent primitive probes for flyby. That means it will just go around moon, take few snapshots, few pictures, and then mission is over. Then regular orbiters were sent. Orbiters are basically satellites which will operate in a continuous manner around moon surface. And then when further technology got developed, people developed capabilities of landing on other bodies. So they started also sending landing probes, like Apollo were the landing probes. They landed on the moon surface. They were manned landers, but later on and before that, Russians sent unmanned landers also. And then rovers will also come out from these landers. Landers will stay at one place, but there will be a rover which will come out and it will go around, let's say 1 kilometer or something like that around lander so that communication happen. And then recently, of course, Apollo itself was a sample mission return. A lot of, full 3 truck full of rocks were brought by these 12 astronauts from the moon. But recently China has also put an unmanned sample return mission. That means robots are collecting the samples and they are bringing it back to the surface of Earth. And then, of course, manned mission is the only Apollo missions which has happened. So this is the kind of activities people have done world over for the exploration of moon surface, or which we see every day. This side is known as the near side of the moon. And one fact you may be aware that we cannot see the other side of the moon from Earth. Compared with moon, it has a lot of gaddhas, a lot of pimples are there on the moon surface. So you can tell those poets moon is not a good entity to be compared with. So there are a lot of impact craters, and then these dark patches are there. And these brighter rocks are basically the lighter elements, rocks made of calcium, silica, nickel. So any calcium-dominated rock, even on Earth, they appears much brighter or whiter in color. So that's why these rocks are basically white in hue or in color. And there are dark patches which are basically predominantly the basaltic rocks which has variable mineral compositions. The probes around the moon. So the first probe which was sent was called Chandrayaan-1. It was sent in 2009 and it has almost 10 instruments coming from different countries. I will not go into the details of the names of these instruments, but these sensors were basically meant to take high-resolution photographs, even third-dimension photographs of the moon, and in different wavelengths or in different colors. So this is how the spacecraft look like. And then it's not important to have only, so we have developed infrastructure on the ground also. There is a huge antenna. Madam is sitting, she is operating antennas for receiving Earth observation data. So same way for all the planetary missions, because the satellites are very far, they send signals. The signals are basically coming from a long distance. From Mars, it takes 20 minutes for signal to come over here, 12 minutes rather. So to capture such signals, you need to have a very large aperture, large diameter antenna system. So this is a 32-meter antenna there in Bangalore. It is called Deep Space Network, Indian Deep Space Network, IDSN. So such type of antennas are basically used to communicate with these, far-off probes, like any probe which is going around moon. So they also send commands and they also receive these images. So this type of ground infrastructure is also generated in India by our own scientists here in ISRO. Chandrayaan-1 found water on moon. A lot of people know. How does it find? We will see. Then it also found that there are, even though the moon does not appear to have volcanic activity now, but in geological terms, it had volcanic activity until recent past. That also evidences were, established. And then remember that global magma ocean hypothesis, we also got some evidence of rocks which are basically lighter and heavier at different places depending on the origin. And that hypothesis got confirmed by these observations which are provided by Chandrayaan-1 data. You remember, you take a small stone and then put in the pond of water. What will happen? The water will splash out. So a lot of splashing happens, even in this case also. So this material or these splashes are known as ejector. So a lot of material will get ejected out. And the material which is below, at the lower layers, it will get now exposed. So the craters becomes a very unique place to understand and to know the geology or the composition of the rocks which are at the lower strata, which are not seen. So that is why impact craters are very important. And this is how suddenly, this transient cavity, when it basically subsides, you will see that some of the bigger craters, they will have this, ejector material, then rims of the crater will form, and then at certain craters which are bigger in size, more than 25 kilometers or so, there will also be an impact by the body itself. Every action has an equal and opposite reaction. So with that process, with the law of Newton, the moon will also rebound, and this rebound will create instantaneous hill. And these are all called central hills. So in all craters will not have, but craters which are larger than 25 kilometers in diameter, people have seen that such type of central hills are there. Now all of you have 30x, 40x mobile zoom cameras. So on a full moon night, you can zoom towards moon, and in the southern half of the moon, you can see this beautiful impact crater, which has long rays, here a lot of rays are going out of this crater. And this crater is called Tycho crater. There was a French astronaut called 𝗏𝗏𝗥𝗍 on the name of Tycho, this particular crater has been named. In fact, there is a Bhabha crater also. So all big people, they are sitting with the names on now moon. So there is a Jawahar-Sthal, there is Bhabha crater, and then all big astronomers, they have craters on their name. Now, if you jump from here to here, you will be jumping around 4 kilometers. So 4 kilometers of crustal material has been excavated. This is such a huge impact. And there is a beautiful central rise here. This is that central hill, that action versus reaction, that happens sometime in home also, no? When mom gives you a cling here, then you will get a bulge. So same bulge is here. This is the lunar bulge. This is that central rise here. This is around 1.5 kilometers high. So this is the kind of, terrain you see when you see moon with very high resolution cameras. Very rugged terrain, all kind of, geologically complex features, morphologically complex feature, boulders here and there lying down. And then we have a camera. So this is the largest basin on moon. This has around 1,000 kilometer diameter. And it's a mosaic, the many strips of Chandrayaan data are stitched together. So you can see this beautiful multi-ring basin. You have one ring, then there is a second ring, then third ring, and then once one crater has happened, afterwards also impact craters have happened. So there are multiple superimposed craters also you can see in this beautiful place called Mare Oriental. And when such type of huge impacts happens, there are other impacts. This material will go, a lot of material will go in air, and then it will start falling. So these are called secondary impact craters. So you see here, this bullet type of, somebody has punctured 1, 2, 3, 4, 5 in linear line. So material has gone like this, and they are now falling like a, bullets onto the moon surface, and they will create what is called as the secondary craters. So these are all beautiful lines of secondary craters you can see around this Mare Oriental. So people have basically seen that the secondary craters, because impact was so huge that up to thousands of kilometers, material will be thrown out. And some of this material also fall on Earth, and people call it, what is known as, people collect meteoritic samples. So you get meteorite samples from moon, you get from Mars, especially in Antarctica. So some of this material, because of impact, it also falls onto the Earth surface. And planetary scientists use that material also. Yeah, these are all again secondary impact craters. This is another beautiful crater. It is not very deep because it has been filled by the lava flows. So it looks like a thali. So very unique shape. And then there is another secondary impact crater has come over here. Then on moon also you have the snakes actually. There's a lot of snake type of features. So they are called basically the lava tubes. So the volcanic material must have flowed through these tubes, and they have formed this type of very, sinus kind of features, a very long elongated feature. This is a very famous feature. It's called 𝗏𝗏 This is how it looks. Apollo 15, astronauts, they landed here and they have taken the photographs of this depression. This is a depression. Some of you may be seeing that this is not a depression, it's an elevation, but if you carefully see, this is a depression on the moon surface. This is how it looks like. This is the actual photo on the moon, and this is the satellite image. So I will not go into details, it is more a bit scientific, but using this type of observations, different type of minerals have been found. We also found water onto the moon surface by mapping this type of absorption features at around 3000 nanometer, which are indicator of water. And using this type of indications, only people found water on the moon surface, especially in the polar regions. Okay, then there are a lot of young volcanic, eruptions are seen onto the moon surface. So these are all some of the interesting scientific aspects. Some of you can study them. These are faults actually. So material has, collapsed at many places. One can measure the fault lengths. So all these images, all this data, some of you are interested, even though I know some of you are too young, but many of you are, even though you are young, but very bright and very, very inquisitive also. So if you can play with these images, many of these images are available free of cost. Some of you can go to these websites of ISRO, ISRO Science Data Archive, ISRO Science Data Center, and these images you can download on your home, computer itself. You can start visualizing these images in 2D, 3D, make, your computer, that backdrop and all those type of things. A lot of stuff can be done. In fact, we were planning that we will have some moon-thon or some like event for students and all, where some of the students can learn more about the morphology or the morphological features about moon. But I thought some of you can explore this data. All planetary data from ISRO for different mission, either from Moon, Mars, is absolutely free and is available for students, research community. Anyone can access to it. Now, the things does not end here. The story is not over yet. We have a lot of things to do. And some of you can also get excited and then think of becoming lunar scientists. We call them lunatics. Don't become lunatic, but become lunar scientists. And then we are planning missions. Now ISRO is planning Chandrayaan-3 mission, which is again we are going to attempt landing. Last time it could not happen, but this time again we are trying to land so that our lander can land in the South Polar region and then a rover can come out and we can do more experiments on the moon surface. Then ISRO is also planning with Japanese space agency JAXA an exclusive lander mission called LUPEX, Lunar Polar Exploration Mission. This will be again big rover going on a moon surface. Is like a your toy car which you operate remotely. So we'll operate it sitting here from Earth. It will go around moon surface and then make a lot of experiments about lunar water and ice in the polar regions. Then Chinese and Russians also have a lot of plans. Artemis I talked about. NASA is now planning to send back humans onto the moon surface in next, we are now already in 2022, so they are targeting 2025 and 2030 in that time frame, depending on the fund situation. Now funds are problematic everywhere after COVID. So let us hope that humans will return back again to moon with the Artemis program. And you will come to know, some of you young people, young students, you will have a lot of excitement in times to come to know more about the moon surface. I'll leave you with this beautiful image that we have busted a lot of lunar myths. A lot of information through these missions about moon has come up. But still, there is a long way to go to uncover many more myths. And some of you can be helpful. You can be instrumental in solving this. Look at this beautiful picture on the moon. You know what it reminds you? Morning, sometimes your mom is giving milk with Bournvita. And when you make those swirls, this type of swirls are formed on that. So these are all called lunar swirls. Like some milky chocolate milk powder is spread over the lunar surface. So they have been basically now termed as lunar swirls. So this place is called Vignanam swirl. And how the swirls are forming, what is the composition of swirls, how does they form? There are some scientific theories, but conclusively we don't know. So many mysterious stuff is still there on moon, which is unresolved. A lot of scientific questions are there. And I hope that some of you young scientists, some of you, at least one of you, or 1, 2, 3, whatever number, you can get excited about moon and then start thinking about it. There are other things which we did not talk about, like helium traps, bringing helium back to Earth and using it as nuclear fission, and stuff like that. So there are a lot of scope as far as lunar studies are concerned. So on this occasion of International Moon Day, I hope that you must have got little bit more knowledgeable about the moon and what is happening on moon. Thank you very much to each one of you.
So the talk of my presentation is Luna, the Earth's moon. So how many of you are aware about this fact that Earth's moon is named as Luna? So not only Earth, all planets have moon. What you are seeing on the night sky, it is moon of Earth, which is named as Luna. Its name is not moon. Okay. So all planets are having, not all, most of them are having moon. And this is one of the earliest picture which is made by Galileo from the telescopic observation of moon. This is one image from India's Chandrayaan-2 TMC image, Chandrayaan-2 mission data. So outline of my presentation will be basically focused on solar system formation, then moon's formation from Earth, and then origin and evolution, and some interesting features. So all of us know that our planetary system is divided into two parts. One is this terrestrial planets, Mercury, Venus, Earth and Mars, and then Jovian planets or outer planets or gas giants, Jupiter, Saturn, Uranus and Neptune. All of them are revolving around Sun. How many of you know Kepler's law? Have you studied Kepler's law? Kepler's first law is saying that all these planets are revolving around Sun in an elliptical orbit. Elliptical orbit means like circle is having one center. Like circle is having one center, ellipse is having 2 points which are called focus. Okay, so planets are orbiting in elliptical orbits with Sun at one of the foci. So how this solar system formed? So this is the most accepted hypothesis, nebular hypothesis. Most of you have studied in schools. There is a hot gaseous rotating gaseous cloud which collapsed under gravity. Because of sinking, it is started rotating faster, and because of faster rotation, it flattened to a disc-shaped structure. All denser material come together towards the core, which forms the proto-sun, and that evolved to the present stage of Sun. And the outer material, they form the protoplanetary disk. In any kind of hypothesis, if we see the formation of solar system or formation of moon, always there is formation of disk. This is important. After this formation of disk, then there is accretion. You know what is accretion? When they came together, they collided and they form a larger mass. Small objects collided to form larger mass. That is called accretion. So these interstellar dusts or the particles which are in the disk, they collided to form planetesimals. Planetesimals, they collided to form protoplanets. And these protoplanets evolved to present stage of planets. Coming to Earth-Moon system, as planets are orbiting around Sun in elliptical orbit, similarly, Moon is also orbiting around Earth in elliptical orbit. So when it is elliptical orbit, I have told you that planets are orbiting in elliptical orbit and Sun is at one of the focus. Sorry, Moon is orbiting around Earth and Earth is at one of the focus. So there will be one nearest point, one farthest point. So the nearest point is called perigee. For Earth, if it is nearest to Sun, it is called perihelion. Have you heard this term, perihelion? No. So when Earth is nearest to Sun, it is called perihelion. When Earth is nearest to Moon, it is called perigee. When Earth is away from Sun, some missions which are still operational, like LRO missions of NASA, it is giving us 0.5 meter per pixel. You know what is pixel? All of you are having mobiles with 32 megapixel, 64 megapixel, 120. So this is giving some number. What you are having 34, 128, this is giving some number. As the number is increasing, your picture clarity is increasing. So resolution is decreasing. Okay, that 0.5 is decreasing with increasing number of pixels. Okay, so it is having higher resolution. 0.5 meter per pixel means we can zoom up to a feature which is 50 centimeter. We can see up to 50 centimeter using these datasets. Although now we are having Chandrayaan 2 datasets, the only mode of erosion is impacts. The only mode of erosion and the primary important feature on lunar surface is the lunar study important or 𝝅 to study Moon. I have already told its entire surface is exposed. There is no liquid water, there is no ocean. Can you access ocean floor? No. But you can access lunar surface entirely. The ancient history is preserved. Even the solar system impact records are preserved on the Moon. Because what has happened to Moon, it has happened to all terrestrial planets. Okay? So volcanism and tectonism in absence of plate tectonics. Although there is no plate tectonics, but still we are having volcanism and tectonism on the Moon. Water ice in the polar region. These are the primary things for which long-term human missions are being planned. So how did Moon form? There are several hypotheses, like Earth was spinning and some mass came out like daughter. The Moon is generated from Earth like daughter. There is something which is rotating, some materials, some extraterrestrial materials, they are revolving around Earth and they are captured by Earth, like wife. And there are like several debris which are formed from same nebula. Like Earth is formed from nebula and these materials are also formed from nebula, and they're co-accreted, means Earth is also accreted and they are also accreted together. So it is called co-accretion, and the widely accepted is the giant impact or the big splash theory. So there was an object called 𝗧, which is having a mass, which is having a size of Mars, present-day Mars. It collided with the proto-Earth. Proto-Earth means it is not completely evolved. It is not completely evolved as it is now. Okay, so it collided the proto-Earth, and some debris they go out or they removed from the Earth, and they are captured by Earth's gravity, which form the proto-lunar disk. I told this disk is important in every kind of formation, even if it is solar system formation or lunar formation, there is a formation of disk. So this disk is formed because of this ejection of this debris. Okay, and certain elements they remove to outer universe, and certain elements they are captured by Earth's gravity. They collided and they formed Moon. As this accretion process, this collision and becoming a larger body, this accretion process took very small time. It is like less than, it is like 100 million, some 100 millions of years it has taken to form the Moon. Whereas in geology we talk about billion year time scale. So million year is coming recent or very small. So within this small time interval Moon is formed. So there is a generation of huge amount of heat. When two bodies collide, there is generation of heat. So because of this heat, there is formation of one magma ocean. Although there are two hypotheses, whether it is completely melted or it is partially melted. The Moon is either completely melted, which is forming the whole Moon magma ocean, or the shallow Moon magma ocean. Then this magma ocean, from this magma ocean there is crystallization and differentiation. Like Earth is differentiated into crust, mantle and core. Similarly, Moon is also differentiated. The denser element went down and the lighter elements came up. Impacts are also happening today. This is one image which you can see. It is taken in Apollo 15 in 1970s. It is taken, and this is LRO mission data which is acquired in 2009. So within this time period of 41 years, you can see there is a change. This crater is formed. Here it is absent, but here it is present. So it is the youngest crater on Moon. It is believed that it is youngest crater on Moon, and its age is not more than 41 years. After this impact cratering, huge bombardment and all, the surface is fractured. When the surface is fractured, there is filling of these gaps or these depressions through marine deposits or basaltic deposits or volcanic deposits. So volcanism also was there from 4 billion year to 1 billion year on Moon. There are cones. These are certain examples of volcanic cones on Moon. It's similar to Earth's volcanic cones. Then these are lava flows. Last slide. These are certain lava flows which are called rills, volcanic rills. These are formed because of flowing of lava. And this is lava tube structure. This is from Earth, example from Earth. And this is a lava tube where the surface is collapsed. The surface is collapsed, forming the pit holes. Then coming to tectonic features, there are three basic type of tectonic features. One is wrinkle ridge, which is formed in the basin region. Basically, it is formed because of contraction of basalt, contraction of marine materials. It is formed because of that. And then this is grabens, which is formed due to extension. And this is starch, which is formed because of global cooling of Moon. Global cooling is resulting in contraction. Because of that, it is formed.
For the first launch, so far we have achieved more than 200 missions successfully. These 200 missions, which includes 114 satellites from different categories, like your remote sensing, communications, space missions, and space science and navigation satellites. So all these satellites were grouped under different categories, and those were launched successfully. This mission, which also includes 13 student satellites. So student satellite means many colleges students, they will be doing a small satellites based on their study and their project along with the ISRO. So ISRO also will help them to design and develop that small satellites, and those satellites being launched by ISRO also. So when you come up in your degree level or something, after going with your engineering program, so you can also do a small satellites. So that opportunity I will explain little later also. So we have also done that few experimental missions to come the future programs which we are going to face, and like human space program which is going to come up in the near future also. So in February 2017, we could be able to achieve one successful launch of 104 satellites in one launch vehicle. That is 101 satellites from various foreign countries, and from India, 3 Indian remote sensing satellites were placed under one launch vehicle, and we could be able to launch successfully, and all the 104 satellites were functioned very nicely, and there is good feedback also from those countries what we have launched for them. So there are 3 major components which basically ISRO is addressing. One is launch vehicle part, another one is a communication part, and another one is our remote sensing component. So basically what is launch vehicle? So launch vehicle is that nothing but you are carrying the satellite and keeping at different altitude. You can say that around 400 or 500, whatever the altitude you require. So based on that, we will be selecting the launch vehicles. So there are different type of launch vehicles we have shown here. So all these launch vehicles, we have kept a display outside. You can also go and see there. So in the exhibition area, we have put these satellite models, we have launch vehicle models, we have placed there. You can have a look also. So another important factor is that we have one more thing is, presently we are having only one launch pad at Sriharikota. So the second center is coming up near Thoothukudi in Tamil Nadu. So basically the difference between these 2 places is that if you launch from Sriharikota, to avoid that any damage or any assessments should not fall in the land portion, so we have to take a launch vehicles like deviation and put the satellite in the required orbit. So we have to take a deviation which will consume more fuel. To avoid that, we are coming up with this center that is in Tamil Nadu, Kushegarapatnam. So from there, if you launch, that launch vehicle need not be consuming more power to put the satellite at the required orbit. So that will be very good for us. So hence we are developing this site. Most probably that will be in operation in a year or 2 also. Apart from that, also you are watching the TV using only this communication series of satellites. And there are various applications like ATMs, oil and gas company, that is VSAT services, which we are providing from this INSAT series of satellites. Now coming to remote sensing, see, our journey started in 1988. That is our first remote sensing satellite, IRS-1A was launched, which was having a resolution of, spatial resolution of around 72 meter and 36 meter. And later on, we come up with the improved version around 5 meter in 1995, that is IRS-1C satellite. So that has given a very good results. In 1995, at that time, ISRO was the top #1, because in those times, only ISRO is giving very good high resolution data from Indian remote sensing satellites. Then we came up to various programs we could be able to cover, and today's technology we have up to 30 centimeter, that is Cartosat 3 data, which is given from the remote sensing satellites. And these are all the different capabilities and spatial domains, how it is being explained. If I take a 1 kilometer spatial resolution, you will cover a very large area. If you take a small, high resolution around 65 centimeter or 30 centimeter, you will cover only a very small packet of land. But the level of information what you are getting, that will be too high in the remote sensing images. So remote sensing is nothing but you are studying about an object or changing phenomena without contacting to them. So for that, you will be utilizing from the electromagnetic spectrum. I think you are already aware about that electromagnetic spectrum. So in that spectrum, we are using visible spectrum and infrared and microwave region to capture the images. The energy, whatever the recorded signals, it will be transmitted to our ground station at 𝗧𝗦𝗥𝗢. So we will downlink the data, and from there it will be sent to processing center, where we will process into the final output, and then it will be transferred to the various users like your Forest Survey of India or Central Water Commission. Many users are there, they will be analyzing the data. So these are all the different type of orbits which normally we place our satellites. One is polar orbits, where our remote sensing satellites are being placed from north to south, it will be rotating it, and your geostationary, it will be focused to the one point. So that's why you have orbits which are there, daily it will cover that entire globe. So all the remote sensing satellites, if I take it, it will be covering around 14 orbits. All the blue lines, what I am showing is the orbits. So all the 14 lines required to cover the entire globe. And this circle, what you are seeing, the red color, that is our 𝗧𝗦𝗥𝗢 ground station visibility. And there are different mechanisms they were using in the starting period of the sensors. I mean the platforms, how they were kept. Initially they were keeping the very high, okay, very high, and then they were collecting the ground level information, and later on came to aircraft, and then later on space shuttle, afterwards satellites. And today technology, you are also able to get the ground level information using the drone. So you can also fly the drone and collect the data about the ground. That is also available. Apart from that, this is our NRC role. What normally we do is, our main focus is for data acquisition. So we will be collecting the data from various satellites and processing it and giving to various departments. And we are also providing the aerial survey facility to majorly for disaster time we will be giving, and then we are also giving the training and outreach facility to various departments like universities and so on. This is the one small video how we are collecting the data from satellite at our 𝗧𝗦𝗥𝗢. I am just showing that. So whenever that satellite comes out of visibility, so our antenna and the satellite both will be synchronized, and then it will be receiving the signal. Once it has gone, then it will be come back to the normal position. So those operations will take maximum 10 to 12 minutes only. So this is the polar satellite remote sensing data, which we normally collected from that. And this is the pictorial representation how your data is collected and stored in this control room. And we are also having one more ground station where in Antarctica, that is Bharati ground station. So this ground station is having a facility to connect our remote sensing satellite in all the orbits, because it is there in the location in such a way that we have selected. We could be able to communicate with that satellite or uplink or downlink, anything we can do it from all the orbits to the satellite. So then now coming to various applications point of view, how remote sensing satellites can help in various applications like agriculture, water resources, natural resources and forestry, and for your urban growth. Various things one can do from the remote sensing data. For example, if I take agriculture, as I said earlier, I can be able to map the entire country, how is the crop condition and what is the crop level of information and what will be the yield it can give. So those estimations I can be able to easily predict using the remote sensing data, and those inputs we are preparing every month and giving to Ministry of Agriculture. Like that, we are giving various inputs to various departments to respective their application areas. For example, water resources commissions, we are giving about the inflow and outflow of water of various areas, and similarly for urban department, we are giving the information about how urban growth is happening there at various levels. All these things are being given to them. You can go to school and then log into this Bhuvan website, and you will get various level of information about the thematic services and disaster services and hosted services. Various application informations are being given in this portal also. We are also giving various platforms like visualizing the data. 1 meter resolution data you can visualize over the entire Indian region, like Google Earth. You are seeing the Google Earth image, so similar way you can also see in this, our Indian region, with our Indian satellite data at 1 meter level you can see in this portal also. We have put steps in two missions, that is one is Chandrayaan-1 and another one is Chandrayaan-2. So Chandrayaan-1 we are able to do it in 2008 and Chandrayaan-2 was in 2019. So more details you will be hearing in the afternoon. So I am giving a gist of it. What are the sensors, what are the applications, what you could be able to do it in this Chandrayaan-1. There were around 11 payloads and the main is discovery of water molecules on the surface of the Chandrayaan-1. So those informations will be detailed way we will be discussing in the afternoon also. And another good example is, future program which we are coming up with is human space program. See, many other countries already they are sending human space. They are coming back and they are staying there 5 to 6 days or whatever the time required, and they will be doing the space research analysis and coming back safely. Similar way, ISRO also is planning their first step in the human space program, and this is the first 𝗬𝗏𝗏 lady, that is a robot. So she will be flying first before the human space program. She will be going there and she will do the operations of whatever we designed for this human space program. And then human will be sent into the space program. And this is one of the example in the forest area, how the group of elephants or animals movement, we can be able to see the track, where they are going in, we can easily able to predict. And this is one of the change in direction which I was saying there. How satellite data one can study from various resources, you can see that. The building initially it was there or not, or how much development has happened, everything we can. I have just collected few images of the same area to different intervals, so overlaid one over the other and produce this output. So this level of information, anyone can do it. Okay, there are open source software is available, QGIS. Using that, you can also get the images of different interval time of the same area, and you can also develop and see that also. Another good example in the desert area in the Rajasthan, how that dust storm is coming up. See, just I have taken only 2 images and I am showing that how the dust storm is and how the sand dunes are got disturbed. You can see that also. So like that, if I take a continuous images for 1 month, I can be able to tell that clearly in the interval of dust storm, and we can give the information to the local authority to take care precautions also. So with this, I am finishing my lecture, and thank you very much for listening.